Hello, Maurieo! In this video I'm going to calculate an intersection. The classic situation where you have set up from two known points and observed to a point that might be slightly inaccessible. The job here is to calculate the coordinates and in this instance the height of C. So here we are, we've got the coordinates of A and B, we've got the instrument height at A and B, the zenith distance to C, and then we've got in here the angles that we observed at A and B. So first thing we've got to do is calculate A, the missing line on coordinates between A and B. Now I've shown you videos on how to do that, so if you've stuck with that, go and have a look at maurieo CALCS AN Missing Line or one of those on my video channel. Now having done that, the next thing we can do is calculate angle C, because we know, clever people that we are, that the three angles of a triangle add to 180 degrees. So here we are, we've got 61, 42, 20 plus 42, 39, 20, add them together, A plus B, and then we subtract that from 180, which I can do this way here, 75, 39, 20, and then check that it actually adds to 180, 75, 39, 20 would be the angle at C. Now let's work out some bearings, because we're going to need some bearings to get the coordinates of C. So we start with 105, 35, 30 AB, and from that subtract 42. So that's going in that direction. Subtract 42, 39, 20 gives us 62, 56, 10 to AC. Now we just go to C and come 180, reverse down that 242, 56, 10, that's C to A. Take off our angle 75, 39, 20, and we get 167, 16, 50, our bearing C to B. Now a lot of people might stop there, but not us. We're surveyors, we carry on, we do our checks. 167, 16, 50 we've got there, and if we take 61, 14, 20 off it, we should get 105, 35, 30. And there we go, sure enough we do. So that checks out. We know we can carry on with confidence. Now to calculate the sides here, of course we've got two angles, one known side, or three angles, one known side. Sine rule springs to mind straight away. So I've written out the sine rule here for AC. It's a pretty simple rule, and here we've got AC, which is equal to 356.685 sine 60 blah blah blah, as the sine rule does, and we get 324.125, which I've shown here. Similarly, we can work out BC, again just using the sine rule, 349.463. Now I do have other videos that will show you how to use the sine rule, so I'm not going to repeat myself here. So moving right along, we now of course have our triangle fully calculated with bearings and coordinates and distances. So let's do some calculations. So we're going to go from A, which we know, to C and back to B, and that should, if that closes up pretty good, we know we're on the right track. So 62, 56, 10, 324.125 to C, and from C to B 167, 16, 50, 249.463, and as I've shown in previous videos, ordinates, coordinates, and calculating Travis coordinates, these quite easily done. I've just done this on my calculator, my trusty HP15C, which I'm not going to bring out today, and there you go. I came through convinced that I ended up on the same one, 0, there and there, so very good, very very tight close, and these are then my coordinates of C, which I've shown here. Now all and written up here again, yes, 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 and now all it remains to do is to find out the height of C. So the RL of A, 72.564, delta H to C would be 324.125 over tan 85, 11, 09. That's the zenith angle, and that straight away that gives us our difference in height, and there's our height of instrument at A, which we would add on, and that gives us 101,519, 101.519. RL of B, height delta H to C is 249,463, their distance there, over the tan of 82,0614, our zenith distance, 34.599. Height of instrument at B, 1.458. Add them all together, 101,521. Oh, that's pretty close. Let's take the mean, and we get a mean RL of C, 101.520. What could be easier than that? And there you are. We've calculated an intersection just by observing angles without doing any measuring. It's perhaps a situation that it doesn't arise too much these days, given our ability to measure is greater than what it was, but there are still the odd inaccessible points and things that we may wish to measure to. And now we've got the knowledge of how we can go about